recap where we stopped. Last lecture we stopped at example 1, where we analyze this network here, and then we transform this bubble, this node here, station number, and the 3 types of time below the balloon here. All right, so you have the most high frequency, most probability, optimistic time, and pessimistic time. And then you use a table to calculate the mean time. So we have A, M, and B. So we calculate the mean time, and then we find the variance. Okay, so once we have the mean time, we follow the prerequisite relationship, and then we build from this one and this table, the mean time especially. So you replace the 3 number here with the mean time in this table. Then you convert, okay, you convert into the matrix diagram, okay, into this diagram. All right, so the exercise of finding the numbers of these two, right? These two we use forward pass, and these two we use backward pass. And from this diagram alone, you should able to identify which one is the critical path or critical activities. You check these two, it is the same. These two, it is the same. But it's sufficient to check either one. Yeah? Either this one or this one, they are the same. Then they are the critical activities. And then you follow the arrow. So then you form the relationship that will tell you that is the critical path. Okay, and the critical path means that the projects that not able or not allow you to further delay. Okay, if you delay one of the critical path activities, it will jeopardize, or it will disturb the overall project schedule. All right. So, okay. Then we also cover what is slack time. So from table, you can find what is the slack time, or even from the diagram itself, you know what is how to calculate the slack times. Okay. And we also covered from the slack time alone, you identify the critical activities, and then you find the variance of the total projects. You just pick the critical projects variance, you add them together, you get one value, which is 6.89 weeks. All right. So this is a variance that you should aware. All right. Okay, now we look at, yesterday we stopped at here, or previous lecture we stopped at here. Next we look at example number 2. We're still using the same example, but we further using some additional steps to analyze the data. So now example 2 is asking us to do some probability analysis where you need to draw the histogram. Okay, so now the company has told his customer that the new order purchasing system will be operational in 30 weeks. What is the probability that this system will be ready by that time? Okay, so from here, from these statements, you use the previous data to do some statistics analysis here. So recall, when the question asks about probability, you use probability equation, z equal to x minus mu divided by sigma, which is your variance. Okay, and this one without square, without square. So you will use the data in the table. In the table is square, so you need to square root the data to use this value. Yeah. Okay, so the rest is already covered in the previous slides. Just to explain what is all this numbers. So we know that our calculation for the previous one, we already identified the critical activities. Means we already add up all the variance together, we get 6.89 weeks. And to use this equation, we need to square root this value so that you can substitute inside here. When you square root it, you get 2.62, the variance. So later you substitute this value below there. Okay. Now the mean value for the time is 25 weeks. Right? And our proposed project completion is 30 weeks. So in this statement, the boss tell the customer we can ready in 30 weeks. All right. Now you might ask, how do I know it's 25 weeks mean? You go back to the previous data here. You have a mean time here. So you add all, divide by 11. Oh no, sorry, not mean time here. Okay, mean time will be given in the question. Mean time will be given in the question. Latest finish time. Okay, here you have latest finish time, which is in this diagram here on this table that you copy from this diagram. You know that the latest these projects can finish is 25 weeks. Okay, so this one is from the table. You read from table or read from the diagram. So you know that if anything is nothing wrong with the projects, there's no delay. The calculation from the table here is 25. Okay. So the earliest finish time is 25 weeks. Latest finish also 25. Okay, so you use this value. You know that when your calculation is 25 weeks, then you go and promise your customers you need to mark up the numbers. If not, you are squeezing your resources. All right. So your calculation is 25 weeks. Now your big boss tell the customer we able to complete within 30 weeks. Okay. So your mean is 25 weeks. Okay, inside here. Okay, maybe I move to this side. So from the diagram itself, you know that the last station here is 25. So this is the mean time that you use in the calculation, right? In this calculation, yeah. Right. Okay, so we have cleared the 25. Now, how you use this equation? Recall back what you learned in your statistics chapter. Z equal to your target. Your target X is your target. So now the boss tell the customer, expose the customer that okay, we able to complete within 30 weeks. So you put the target time 30 weeks minus the mean 25. Again, how you find 25? You read from the diagram or from the table. You check the latest finish time 25. Okay, and then the variant, how you get 2.62? You remember in the previous table is your calculation is variance square. So you need to square root the number. Don't use this number. Okay, just take note on this one. This will be the calculation error that some student will have in the test or exam. All right, so make sure you take note on this one. Do not substitute this value. You need to square root the number to substitute this one without the square below there. That's why you get 2.62. Then the Z value that you get is 1.91. Okay. Now, as you can recall from the statistic or probability chapter in your Max 2 or Max 1, you know that the next step, once you get this one, is to refer to the appendix. Right, so in your tutorial handouts, I attach the normal distribution table that you can practice. And even in the coming test or exam, you're still seeing the same reference table, right? So we go to the reference table. This one is what you will see. Maybe without this one, but you will see the same table in the test or final exam. Okay, and again, on this reference or on this table, it already give you the equation, how to calculate the Z. So there's no reason you can forget. There's one very, very small equation here, but you can zoom in to see the equation for the Z. Okay, and even tell you where is the position. Okay, and for this module, we only interested to for these two column only, this one and this one. The rest you can ignore at this moment. Right, we start from a normal distribution 0, 0, which means this one is 0. This line, center line, we chop at 0, 0. So you read from 0, 0, using the Z value, read the 0, 0. Okay, so this is the very automatic, very self-explainable steps. Once you get Z, you refer to this table. And just to recap, just to help you how to use this table. Z equal to 1.91, right? 1.91. So you go to this table, go to the far left column there, look for 9.81. Okay, so you look through. So 1.8, 1.9, 2.0, and then this one is column 0. This value is 9.81. It is somewhere here. 1.9, you get this value. 2.0, you get this value. Your Z value is 9.81, so it's somewhere here. You need to have a process called interpolation. Interpolation step is further low-level mathematics. You should be able to do it. All right. Interpolation you learn in your SPM or in your secondary school government exam. All right. So this is the region you focus on in this table. Your 9.81 value is here. You need to find what is the value for 9.81 is here. Okay, so you do interpolation, you get 9.81 equal to 4.719. You need to show the interpolation step in test and final exam. Okay, so this is the area that you get when your Z equal to 1.91. Yeah? In the exam, if your Z is 9.81, you give me area value 0.4713, I give you wrong answer. The question asks you 1.91 is not 1.9, yeah? And it's not even 2. If you give me 0.4772, you also get the wrong answer. The rest I don't need to mark anymore because the following step sure wrong already. Okay, so go and revise how to do interpolation. Yeah. So once you get your Z from the previous steps, go to this table, look for where is 9.81, do the interpolation using this number, this number, this number, this number. You will get your area at here. This is your X value equal to 0.4719. Now, what mean by 0.719? All this value here is the probability that the thing will happen. Okay, that the thing will happen. So you see this diagram, right? This middle line is 0. This middle line is 0, which is you refer to the 0 column here, which is it represent what axis you're referring to. What is your Z? Z, if you get positive, again, I repeat, Z, when you get a positive value, your line, this line, This line is on the right hand side of the graph. I repeat, if your Z value is positive, your line here is on the right hand side, and you write here Z equal to 9.8, Z equal to 1.91. You write on your drawing in your answer. You draw this shape, draw this line, draw the center, write 0 here. This is your Z. You write Z equal to 1.91. You draw a line. What is this meaning? What is this value that you find from this table? 0.4719. It means the area inside this graph, the one that highlight in the green color. It means this is the probability that the thing will happen. Okay. If you get Z negative, it will fall on the left hand side. Still the same procedure. The middle one is 0. The Z is negative, right? So you draw a line here, write Z equal to negative something. Okay, then the area you read from the graph here is the area under the graph. Is the probability that will happen in another side. Okay, the area that you read from this table is probability that will happen. So what does this mean? It means if your Z is this one, the incidence, the thing will happen is 47.19%. Okay, why 47? Why 0.47? Because we mentioned before, this graph, the total area under the graph is 1, which means 100%. And we're looking at 0 axis, which means we chop the graph symmetrically at the center. So 0.5 half, 0.5 another half. So this one area is at another half of the positive region. Okay. Go back to the question. Copy the area. Okay, copy the area that you get from the graph just now. Okay, remind yourself the Z value is this one. So once you draw your sketching, this is the answer that we expect in your answer. You need to redraw the graph again, or maybe you can straight away sketch the other half. Okay, so if your line come to this place and it asks you more than 30 weeks, means more than your mean number, you know that the project will finish more than 50%, right? So you need to include another 50% over here. Okay, if the projects can finish within 25 weeks, and now your boss promised your customer 30 weeks, you know that the successful rate is more than 50%, right? So you need to add another half negative side. Okay, and negative side, which is 47.19 here. Okay, so we transfer what we calculate from the table, we combine with the information stated in the question. Okay, so the probability the project can complete within 30 weeks or less. Okay, the word is here. 30 weeks or less means your target date or less. Means 30 weeks or less, you put your finger on the line here. The region to the left of the line, it meets this requirement. Okay, for the cases that it is less than the target time, because this line tell you it is 30 weeks. This line on the graph, it tell you it is 30 weeks. Okay, you already calculated with the Z value. So if you want to find the probability to happen less than your target date, it will on the left hand side area. Means area under the graph push to the left. Push to the left means include this area and this area is your answer. So the probability will be 0.5 plus here. So the probability to happen is the area that you calculate just now plus another half. 0.5 is 0.9719. You convert into percentage. 0.719, it means 97.19%. This is the answer that I expected. This is the final answer I expected in percentage. If you give me 0.719, I will still give you marks, but not a full mark. Okay, you want to get a full mark? Give your answer in percentage. Any question so far for this question? Everyone good? Navin,
Yes,
you okay? Navin, you okay? Yeah.
The mean 25, where
Yeah.
did we get the number from?
Okay, I already explained that one. Let me see if anyone listened to my lecture. Tashnamurti, are you there?
Yes, Dr. I was the one who asked the question.
Oh, okay, you are the one who asked. Sorry, because I can't see who is asking question. Darshan, Guru Darshan, are you there? The hints is at these slides. Guru Darshan, are you there?
Yes, sir.
Your friend asked one question. How do we know your mean time is 25?
So the 25 is the longest duration.
Muti, do you see it? Do you see
Yes,
it?
sir.
Yes,
Highlight
Dr.
with the red arrow here. Okay.
The total
Alright, so
time for the project, is it?
you can say as a total time or the longest time that you will spend to finish the project.
Okay, Doctor.
Okay. You can find from this diagram or from this table here. Your latest finish time or your earliest finish time also can, because usually the last activity will same. If it's not same, means it's not balanced. Means something wrong in your planning here. Okay, just give you some hints how to balance your calculation. Normally, at the last activity, normally you will arrive at the same numbers. Okay. Okay, so if no question, I will move forward. We have a little bit more to learn. So we already tell you how to teach you how to use the table, how to use probability already. Again, there's one catchy word. If you find the Z already, it asks you less than your target time, meaning you need to find the area to the left hand side. Your target area, your target time or target something. Right? I give you a target. Once you calculate your Z, right? Once you calculate your Z, the question asks you, what is your what is the possibility to meet your target or less? All right, meet your target or less. It means you draw the histogram, then you draw the line. It means your target or less is moved to the area to the left. Means it include another half. Okay, so just be careful. This is a positive Z value. So what happens if you have a negative value? Apply the same concept. If your Z is negative value, you draw a line here, and the target, the question asks you about target time or less. You still draw the line and move to the left. Okay, clear? If this one is Z is negative, your line is over here. with negative value. And then the area you see in this graph is the one you highlight from 0 to your z. The value over here is always referring from 0 to your z value. Okay, then you highlight if your z is negative, then your highlight area is here. And the question asks you if your z is negative. The question asks you that your target time is either on time or less than the time. It's always the line to the left. The area from the line of z to the left. So you need to take 0.5 minus the area of this one. Eh? Clear or not? Clear? Eh? I'll give you some hints what I'm going to ask you already. So ask me question if you're not clear.
Yes, doctor, if more means it's like the same graph, then we take the 0.5 again minus the 0.4719, right?
Okay,
If
so
let's say it's more.
okay, so this one, right?
Yes.
So this one is project in 30 weeks or less, meaning you know that it confirm can do one. So it's to the left hand side. So another, you flip the question. If the if the question asks you, it won't ask you more one because 30 weeks or more, it means 100% already. It means it sure can do one, right? Because the minimum time to complete is 25 weeks. So sure can complete one, right? Unless the question on the question that you asked just now, the question will go, you will cut down this value less than the average time. Then you need to be careful either on the left hand side or right hand side. Okay, I'll give you one more example that link to your question. Okay, let's look at example number 3. Okay, number 3. Same scenario. Your big boss tell the customer, we can in your planning, in your team meeting, progress meeting, you already design the planning already, and you confirm can in average time confirm can finish in 25 weeks. And your boss tell the customer, we can complete within 30 weeks. Mean your boss already mark up the time just to spare from delay. Then scenario number, the next scenario happened in example number 3. So the customer come and complain to them, right? Feel frustrated, and they're not able to receive the order on time. So he told the customer that if the new ordering system is not working within 22 weeks, will it will not do any more business with the Tensile company. Means the customer request, the big boss say I can do in 30 weeks, but the customer say no, I don't want 30 weeks, I want 22 weeks. Can you do in 22 weeks or not? So what is the probability that the order processing system will be operate within 22 weeks? Now the boss need to calculate the probability. Is my new system able to handle the customer new requirement or not? You know that your mean time is 25 weeks without any trouble. Okay, without any trouble. So you know that you're not able to cut it short further, 25 weeks. But now customer have a further demand. Customer say, I don't want 30 weeks, I want 22 weeks. Can you do it? You use the same equation, z equal to x minus mu divided by variance. Mean still the same, variance still the same, because it's same process. Only now your target time change. Your target time change. Okay? Z equal to 22 minus 25 divided by the variance without the square, 2.62. Your value now is negative. Z equal to negative 1.14. Once you calculate Z, the automatic next step refer to table. Okay, you get Z equal to negative 1.14. Okay, Z is negative 1.14. Refer to table. First, you ignore the negative first, because this table there is no negative value, all positive value. So you go and find 1.14. Where is 1.14? It's from 0 until 3. Yeah? Of course, this table is very long. I only use this table can be go to more value, but we just want to test the concept already. So we just use a portion of the curve. All right. So if you study advanced mathematics before, there is a log handbook that give you this chart. There's a few pages of this chart. So for our module, I only use one page of the histogram of the normal curve area. So again, go back to our Z value. Z equal to 1.14. So you go to this list here, go shopping here, 1.14. Okay, so again, just to remind, negative means another side already. Negative means your line, this line, is on the negative side already. And your area that you read from this graph is from 0 to the negative value. So it's somewhere within 1.1 and 1.2, because your value is 1.14, right? 1.1, 1.2, so 1.14 is within here. So you need to find your x value here, not x value, but your y value or your p value, unknown value here, between these two values. So you need to use interpolation method. Again, if you're not sure what is, or you forget what is interpolation, go and ask Mr. Google to teach you. Or you can go YouTube, right? Interpolation. Okay, once you do interpolation, you get the area between these two values. You will get 0.3729, which is around these two values. Okay, and you can always check. If this value less than 0.36 means you calculate wrong already. If this value that you calculate is more than 0.38 means wrong already. It should be within 0.36 and 0.38. Okay. You get the area. Next step is to draw the chart. So again, draw the chart, histogram, draw the 0 axis, draw your Z axis, Z equal to minus 1.14, this is 1.14, all right, or this is your target time. Okay, this is your line for your target time, or you can just write Z equal to minus 1.14 or represent your target case. Okay, so this is the area that you read from the graph, or you do interpolation just now. Your area is 0.3729. Okay, 0.729. You know that the area under the graph, half of the graph is 0.5. The possibility that you can complete this project less than 22 weeks. Okay, less than 22 weeks. What is the probability? Right, the customer asks you whether you can complete in 22 weeks, right? Less than 22 weeks, right? The customer doesn't say you can do minimum 22 weeks and above. The customer demand, you must give me maximum 22 weeks. It means in another way around, in mathematics, you find the value less than 22 weeks and not more than 22 weeks, right? When a customer demands something is, right? When the customer order, like for example, order a burger, right? You should give me, I cannot wait at the counter more than 5 minutes. You cannot expect the customer, give the customer more than 5 minutes, right? So this is more, this is less. So this is what your customer want, less than 22 weeks. So this is the area that your customer want to know. Okay, so from this diagram, you should know how to do calculation already. The area you find is 0.37 something. Total area, half of the graph is 0.5. What is the remaining area? You take 0.5 minus this value is the probability of completing the projects less than 22 weeks. Okay, so this is how you do. You take 0.5 minus the area you find in the through interpolation. You get 0.1271 or 12.71%. For this module, for engineering module, minimum 2 decimal place in your answer. Yeah? Minimum 2 decimal place in your answer. And give, if a question asks you about probability, then give your answer in percentage. Huh? Although your answer showing 0.271, I will still give you marks, but not full mark. Full mark with the percentage. Okay. 0.127 is the area under the graph. It's not the correct presentation of the percentage. Okay, so again, your customer want a data 22 weeks or less. Your percentage of completing or meeting the customer demand is 12.71%, which in very, very rare case will happen. And you as a big boss, or you as the one who negotiate the time, you should not agree based on this very low percentage. If not, you're going to make the company lose money because of contract agreement. Okay, if you agree, the customer will be very happy because the customer going to get extra bonus by the end of the year because you're not able to finish and you need to pay the customer some compensate. The customer sure very happy one. Right? So when you go to work later on, when we talk about planning, if you cannot do it, please tell the one who negotiate, we cannot make it. All right. I mean, the percentage of doing it is very low. In this case, it's 12% only, less than 30%. Very, very low. Okay. Okay. However, if the big boss still say, okay, we go for it, then it's okay. You as an employee, you need to remind your big boss, say that we cannot, if the possibility we meet this target is very low, and we might lose some money for compensation. You need to say that to your big boss when you are the one who planning the projects and you are in the table of negotiation. You need to privately talk to your big boss. We really cannot make it. All right. If not, the company will be in trouble. Okay. So this is the one that you calculate. All right. So you reverse engineering this question. If the customer were very friendly one, he asks you, can you give me 22 weeks, but you can give me you can deliver your goods minimum 22 weeks, or you can take more time lah, never mind lah. Means that can you complete your projects minimum 22 weeks, or you can take as long as you want. I'm not in hurry. Then you flip the question already. Then it's the area of this one plus here already. It's about plus another 0.5% here. 0.5, 0.5. If the customer are very friendly, doesn't care about time frame, he say he just want you to, he just give you a target time, and whether you meet the target time or not doesn't matter. Then it's fall under this area and this area. But example number 3 is a very demanding customer. Okay, so then the time frame, the area that we're interested in here. Okay.
Doctor, my value for the area is a little bit different because I use like 3 decimal places, so it's okay, right? And
Is
the
it very
final,
near? What do you
yeah,
get?
it's 37.36.
0.3, right? 0.3 still okay.
And then the
0.
percentage
Means 0. The area you get
3736.
36. How you get 36? You have
The
4
Z,
decimal place here. What? At
the
least here.
Z, I took
Is it a copy here?
1.145.
Let me check. Sometimes I copy and paste from my previous slide. So okay. So area is it correct? Yeah, paste the correct. Okay. So the area you get is what?
3736. 0.3736.
360. Okay. I mean 0. You can see the nearest 3 decimal place is 3. So still okay.
Okay.
If you get 0.78 something, then it's totally wrong. So I still give some rooms for that, but not too much. Okay. So in exam, we have a plus minus value to play around, but not too much. Okay. So if your probability here is if you minus, you'll get 12. Maybe 12.8, 12.6. Still okay, but not 12.5, not more than like 1 or 2%. Right. So anyway, when I do marking, I will still look at your steps. If your step is logical, reasonable, I still give you pass. I will still give you the full marks if your step is reasonable, because I understand when you do calculation, there is decimal place error, or sometimes because of the graph resolution.
Correct.
Okay. Right.
And then the question they can ask range also, right? Like from 22 to 28 weeks.
Usually I won't ask that way lah.
Correct.
Because there are lots of things you need to process before I ask you about probability. So this one is like one subsection, maybe 7 marks or 8 marks, something like that. Very, very small portion compared to the previous one. So I won't ask you more about it unless we are doing statistics chapter. If you're doing Max 2, then then more question about statistics. So this one is just to application of the statistics concept. So I won't go deep into these histogram things.
Correct.
All right. So that's why I mentioned I didn't ask you something more than 0 here. I didn't ask you more than 0 here. If you are doing mathematics 2 or mathematics 1 that related to probability, then we will look into this one. Okay. There's one tool that you can use for project planning, where it's Microsoft Projects. It might sound like a advertisement here, but this is normal tools used by the project manager out there because they tie up with the Windows system and iOS system, right? So this software is called Microsoft Projects. It's fall under Microsoft software. And too bad, I've tried to access this project through our Manipal University's 365 account. Even through Teams also. I not managed to use you can find projects in the Teams, but you're not able to create projects to set. It's a set news. But what is important here is that there's a tools there. There's a tool for to do plannings, all this. If time allowing, then maybe I will convert this using Microsoft Project as your coursework or as your assignment. But at the moment, I will just let this on in KIV first, keep in view first. All right. If we have time, then we go into this one. But because so far I don't have any license to use project yet. Like just now I mentioned our Microsoft 365, we don't have the license to create. So it might be some trouble in some of you, you're not able to access. All right. Okay, so with this, we conclude chapter 3. Okay, conclude chapter 3. Let me stop the recording.